So this is our circuit. You plug in your music player to this cord, and
the music comes in here, goes all the way through our circuit, and controls these LEDs.
The red LEDs light up with the bass tones, and the green LEDs light up with the treble tones. Want to see how it works?
Have a holly jolly Christmas, it's the best time of the year. Now I don't know if there'll be snow, but have a cup of cheer. Have a holly jolly Christmas, and when you walk down the street.
So the first part of our circuit is a filter. On the top part we have a low pass filter, and on the bottom we have a high pass filter. The filters we decided to use are Tighe filters, which are second order active filters. What's interesting about this is that since they have op amps, it works kind of as a buffer, which keeps different systems from interfering. The way that we made the high and low pass filters different is by changing the configurations of the resistors and the capacitors as is shown in the circuit diagram. To design the filters, we looked up easy formulas, and we used those to decide the values for the different resistors and capacitors. We determined these based on the desired cutoff frequencies for both the high and low pass filters.
Because the filters output such a small signal, it needs to be amplified to get to or go through the LEDs.
When we chose the values for the resistors of the amplifier, we had to take into account that we wanted to amplify the frequency by 10. The values of the resistors themselves didn't matter so much as the ratio between the values. Since we wanted it to be amplified by 10, we had the second resistor be 10 times the first. So what we did is we used a 10K ohm resistor and then a 100K ohm resistor.
Because the filter outputs such a small signal, we chose to have an inverting amplifier after the Tighe filter to increase that signal so that it can light up the LEDs. At this point, the LEDs will still blink, but they'll flicker rapidly, and we want to slow this flicker down, so we added a peak detector which smooths out the jagged input signal. The peak detector consists of a diode and a capacitor and resistor. The diode in the peak detector works as a rectifier, which means that it prevents the peak detector from capturing the wiggle of the audio signal. When the input voltage, which is the sound signal, is greater than the capacitor, the diode shorts and the capacitor charges to the same voltage as the signal. Then when that capacitor is fully charged, the diode acts like a wire again, and the voltage on the capacitor decays exponentially, creating a smooth drop in voltage, which then goes through the LED and lights it up so that it...
The values of the capacitor and resistor in the peak detector affect the time constant. If the time constant is too long or too great, then the blinking of the light will last too long. And if it's too small, then you won't really be able to see what's happening. We decided that we wanted a time constant of about 1/4 of a second. So we calculated our capacitor and resistance values so that that would be our time constant.
So now that we've explained how we built and designed our circuit, it seems pretty easy and you can do it on your own.
The other cool thing is even though we have Christmas music and Christmas colors, you can use whatever music you want with whatever colors you want. So it is amazing all year round.
Say hello to friends you know and everyone you meet. Oh, the mistletoe is hung where you can see. Somebody waits for you, kiss her once for me. Have a holly jolly Christmas, and in case you didn't